Hello everyone, this is the second video in the series of videos using Visible Geology for creating geological models. In the last video, we saw how we can create simple models with geological beds, unconformity, different topography, and cross sections. In this video, we will add some structures to our model such as faults, folds, and dikes and see how they appear on map and cross sections. We will then further look into the stereographic projections, which are another very useful tools in structural geology to represent 3D data into a 2D plane of paper. As before, I have provided a PowerPoint worksheet along with this video. The worksheet contains some problems that you can solve using the steps that I will cover in this tutorial. Hope you'll enjoy this activity. Let us make our first model by adding some geological beds. We will first add a dike in our model. A dike is a planar rock body that is formed when some rock materials fills the pre-existing fractures in the rock. To make a dike, we can simply click on the dikes option here. As one can see, these options allow us to prescribe the strike and dip of the plane along which the dike will be made. Let us give us a value for strike and dip. Let's say strike is 0 and dip is 9. There are other options for dike thickness. We will take this as 15 and add the new dike. This is how our model with dike look like. Now let us see how a faulting event affects the outcrop pattern. A fault is a planar discontinuity along which the rocks slide against each other. Study of faults are important because faulting events lead to earthquakes, and in order to understand the earthquake hazards, geologists often study the nature of deformation in faults. So using the fault option here, if we click on the fault option, this allows us to prescribe the strike and dip of the fault here. So let us take strike as 90 degree and dip as 60 degree of the fault plane. If we go to more options, we can also see the rake and slip. Rake here will help us to determine the slip direction, and slip is simply the amount of slip. So we can try 20 units here, and let us put rake is equals to 0 and see what happens. So you can see some change happened, and if we look at the outcrop, so there it is. If you can see on the map view, this dike was intersected by this fault along which some slip has taken place. Based on viewing the other cross sections, you can tell that the slip is only occurring in the east-west direction, as can be seen from here. What we'll do is we'll take another example and take a different value of rake to show a different slip in fault. So this diagram is showing a similar model However, compared to the previous model, here we assign the rake as 90° and the slip we'll assign as 20 units. Note that the strike and dip are same, and we want to compare how the fault outcrop pattern would look like. In the model here, we have selected rake as a 90°. There is no slip observed on the map view, but if we see the side view, we can see that this beds have been displaced. There's a discontinuity here. In this way, we can assign different slip directions and amount and see what outcrop patterns and cross sections would look like. Now let us try to add folds in this geological model. When we click on the fold, we can see what happens to the model here. The red plane here is the axial plane, and we can decide what strike and dip this axial plane has. If, for example, we change this strike and dip, you can see how it is changing. Depending on what strike and dip we assign to the axial plane, we'll have different kinds of fold. The rake here shows the inclination of the fold axis. If we change rake from 0 to 90°, you can see how the folds are changing. And then we have other options to determine the period, the amplitude of the fold, or various shapes. So for now, we'll go with this and add the new folding event. And once you close this, you can see how the beds, which were horizontal at the beginning, are now deformed into folds. And we can try to see how depending on the strike and dip of the axial plane, how folds look like in the different cross-section views and the map view. So a very interesting point that you'll see is that folds generally show repetitions of the bed, as we can see in the map view here. And this is a very common characteristic to identify a fold in a map view. Another interesting feature of visible geology is how we can use strike decal tool to simply put the strike and dip on the map view. As you can see here, similar to a previous video, we can make a cross section along a line segment, which will show how this model would look like along that particular cross section. Now let us look into another interesting tool, which is called a SteerNet. We have covered the basic of SteerNet in the previous video, and here I'll show how to plot SteerNet using visible geology, and more importantly, how you can visualize that in 3D. We can plot a plane. Let us take an example such that the strike is 75 degree and the dip is 30 degree. and define the line difference this and etc. So this is the plane. The plane is plotted as a great circle, and the dot here represents the pole to the plane. The cool part about this visible geology application is that we can visualize this in 3D. So if we drag and drop, so you can see how that plane looks like in 3D and how it is projected on this stereographic projection. Similarly, we can add a line which has a trend of say 113 degree and 46 degree. So the blue dot here represents the line, and again if we try to visualize it in 3D, we'll see, let me hide this for a while, we'll see how this dot is actually this white line that is passing to the center of this hemisphere, and that is projected as the dot on the piece of paper on 2D. I would encourage you to use this SteerNet tool and try plotting different planes and lines so that you can get an idea of how SteerNet works and visualize the planes and lines in 3D. That's it for this video. Thank you.